Hello class, welcome to lesson 8.6, which is all about slope. By the end of this lesson, you should be able to find the slope of a line and use slope to describe a constant rate of change. So let's go through some vocab. Slope might be a word that you've never heard of before, or you might have heard of it outside of the classroom in a non-math classroom setting. So slope is a ratio of vertical change, so how high something goes up. Remember, vertical is up and down, compared to horizontal change, so how far something goes like left to right. When we are talking about slope in math, we write as a reduced fraction. We never convert to a decimal, okay? That's a big difference between slope and rate of change. Rate of change in previous sections, I let you convert to a decimal. Slope, I never want to see a decimal, okay? I want a reduced fraction. Now, some places that you might have heard of the word slope in the real world, as you guys tend to call it, is if you're skiing or snowboarding, the slope of a hill, the steeper the hill, the bigger the slope, okay? And the beginner hills tend to be a lower slope, right? They don't go as steep, so you don't go as fast when you go down them. Slope, I know some of you guys like skateboarding, so the slope of a ramp, a really steep ramp, again, has a high slope, and then a gentle, gradual ramp has a low slope. Okay, the formula for slope is rise over run. We kind of did this without calling it slope a couple sections ago, where you subtract your y's on top, your y values, over, and then you subtract your x values on the bottom. And generally, slope, the variable we use for slope is m. So if you ever see m equals for the rest of this chapter, they're talking about the slope, okay? Okay, so let's practice finding the slope. So here we have a skateboarder and a ramp, and we can see that the ramp is 54 inches long and 15 inches high. So if we want to find the slope, remember we do the vertical number, so 15, how high it is, and we put that over how long something is, so how much it goes left and right. So that's our fraction, that's our slope, except remember, I want you to reduce these fractions, not down to a decimal, but reduce them. So I need to look and find a number that goes into both of those. I know that 2 doesn't go into both of these because 2 doesn't go into 15, but 3 can go into 15 5 times, and 3 can go into 54 18 times. And then I look at this fraction and I say, is there a number that goes into both 5 and 18? No. So my slope of the ramp is 5 over 18. And that's all you have to do. Okay? Find the slope of this kind of story problem. So this time you have words to describe the situation instead of a picture. But we know Kyle is flying a kite, and the kite is 20 feet away from him horizontally. So forgive my drawing abilities, they're not very good, but I will try. So we will say it's 20 feet away from him horizontally, and then 70 feet away from him vertically. So we're going to go up, like that. So then we want to know, this dotted line is his string. We want to know what's the slope of that string. So again, you need to put the vertical over the horizontal and reduce. So why don't you guys go ahead and try to figure out this slope. Good luck. Hopefully you said the vertical is 70 and the horizontal is 20. Sorry, I keep clicking the button on my pen. And then you said that can reduce. I can take 10 out of each of those. So then I have 7 over 2. And that's as reduced of a fraction as I can get. So that is my final answer for the slope of that kite string. So if you're ever given a problem that does not have a picture, take a couple seconds, draw the picture. You can skip the stick person if you would like. But draw yourself a picture so that way you can see what's happening. That usually makes things a little bit easier. Okay, so the slope was 7/2. Now, we're looking at a graph. And when we look at a graph, we use the slightly longer way of finding slope. And that's where you subtract your y's and you subtract your x's. Okay, and I put m equals because remember, m represents slope. Okay, so if I want to do something like this, that means I need two different ordered pairs. So I need my x comma y for two different points. So if I look, where it hits 0 isn't a nice number, right? It's not on 7, it's not on 8. But if I look, this is a nice number. This is at, I go right 8, and I go up 1. So one of my ordered pairs can be 8, 1. And then I'm going to keep following that line until I find another nice point. Like, see, these are between those corners of the boxes. We don't want those. We want one that goes through a corner of a box on the grid. So then I look here. This is 9 and then 5. So 9, 5. So now I'm going to do this process. I'm going to take my y's. So it doesn't matter which one you start with. I usually start with wherever I ended up. So 5 minus my other y value, which is 1. A lot of times I will see students do 5 minus 9 over 1 minus 8. That's not right, because if you do that, you're doing y minus x over y minus x. We want both of our y values on top, and we want both of our x values on bottom. So next, since I started with the 5 on the top, that means I have to start with the x that's paired with it, so the 9. So 9 minus 8. So 5 minus 1 is 4. 9 minus 8 is 1. And then 4 divided by 1 simplifies to just 4. Now, some of you are probably wondering, what if I had started the other way? What if I had done 1 minus 5 over, then I would have to start with the 8 minus 9. Well, let's see what happens. 1 minus 5 is negative 4. 8 minus 9 is negative 1. 4 divided by 1 is 4. And a negative divided by a negative is positive. So you can see both of them end up at a positive 4 for the slope. The only way that you'll get it wrong is if you do not group both y's on top, both x's on bottom, and then keep the ordered pairs. See how 5 and 9 are together in these parentheses? It's kind of like writing the ordered pairs vertically, and then 1 and 8. So it's taking this and flipping it. And if that didn't make sense, but it made sense before, ignore that last comment and go back to before what I just said. Okay, now this problem, I want you guys to try to use this graph to find the slope. Good luck. Okay, hopefully for this problem, you ended up with a slope of 2/3. The 2 points that I found that worked well were 1, 3, and 4, 5. Another point could be 7, 7 up here, or you could even do 10, 9. Any of those points would have been good points to use. And then you can do the y2 minus y1 over x2 minus x1, and you should end up at positive 2 over positive 3. Some people will get this far, and they'll say negative 2 over negative 3. That's not as simplified as it can be because we still have a negative on top and bottom, so you need to make sure you switch it to positive. One last thing I'll say about a graph problem like this is another way you can solve it is once you have your two dots, what you can do is you can say, how far up do I have to go? I have to go up one box, I have to go up two boxes in order to be on the same level as the next point. And then I have to go right 1, 2, 3 boxes. And then you can write it just like we were using pictures. You know you went up 2 and over 3. So the slope would be 2 over 3. Okay. The only thing to be careful is if you end up going down, remember that would be a negative. Or if you had to move left to get to your next point, that would be a negative, right? Okay. Now, find the slope of the line that passes through the points A, -4, 3, and B, 1, 2. So this is the same idea. I'm just going to subtract my y's on top, and I'm going to subtract the x's on bottom. So sometimes students find it helpful if they go through and just quickly label x, y in each one, and then they just pick whatever order they want. So I started with this point, so I did 2 minus 3, so then I'll do 1 minus a -4 on bottom. So 2 minus 3 is -1. 1 minus a negative, that becomes a plus. 1 plus 4 is 5. So my slope is -1 over 5. And since the negative's only on the top, that means there's no negative on the bottom for it to cancel for, so this is my final answer. You could have gone the other way as well. You could have said 3 minus 2 and -4 minus 1, and then you would have a +1 on top and a -5 on bottom. Again, that's the same answer. These are both acceptable answers. Okay, so you subtract your y's on top, subtract your x's on bottom. Why don't you go ahead and try this one on your own? Good luck. Okay, for this problem, hopefully you ended up with a slope of 2. You could have done the method that I did up top and started with the -8 and the -3, or you could have started with the 6 and the 4. But either way, you should have ended up at a +2. If you have questions about that, please reach out for some help, okay? Now, let's talk about 2 more things before I have you guys start doing your homework. So let's find the slope of this problem. So again, I'm going to subtract my y's on top and my x's on bottom. So I'm going to say 4. I'm going to label those. So 4 minus 4 over, and I started with this 4, we'll say, the -3 minus 2. So 4 minus 4 is 0 over -3 minus 2 is -5. And then if you plug that into your calculator and you say 0 divided by really any number, you should end up at 0. Okay? Let's see if we get the same thing if we go the other way. So 4 minus 4 over 2 minus a -3. So that becomes plus. So that's again 0 over a +5. If I plug that into a calculator, 0 divided by 5 is just 0. So my slope is 0. If you were looking at a graph, so let's say this is an XY coordinate plane, then what this looks like on a graph is if you ever have a horizontal line. So that horizontal line can really be anywhere, but this is what 0 slope looks like. Okay? That is what 0 slope looks like. Then let's talk about one other situation. Again, I'm going to subtract my y's over my x's. And then I have 10 minus 3 over 1 minus 1. I get 7 over 0. Now if you plug 7 divided by 0 into your calculator, you are going to get an error. That's because trying to divide by 0 is breaking like math laws. There are certain things that just can't be done in mathematics, and dividing by 0 is one of them. So when you get an error on your calculator that says like domain error or just error or something that does not give you a number, then we call this undefined slope. And for those of you that do not want to write out undefined slope, I'm okay with you guys just abbreviating UND. That's fine with me, okay? If you went the other way and you said 3 minus 10 over 1 minus 1, you would get a negative 7 divided by 0, and you would still get that same error because you're still trying to divide by 0. So you can just say that that is undefined, okay? Undefined slope on a coordinate plane looks a little different than the 0 slope or no slope. Undefined slope is when you have a vertical line, okay? So when you have those lines that are straight up and down, that is called undefined slope, okay? So if you have any questions at all, please be sure to ask for some help. I'm more than happy to assist you. This is a concept that you want to make sure you understand fully because it's going to come back a lot in the next couple of math classes you take next year and continuing into high school, okay? So you want to make sure that you understand slope. And like I said, I'm more than happy to help you. So that is everything for today, and I hope you have a great day.